All right, let's get right into it. In this briefing, we're going to break down the massive shift happening in automotive electromagnetic compatibility. For you engineers on the front lines, you know EMC is no longer just about ticking a compliance box. It's become a serious competitive advantage. So let's start with the single most important mindset change. In this new age of electrification, the very definition of emissions has been turned on its head. We're not talking about chemical outputs anymore. We're talking about electromagnetic interference. This one idea completely reframes the entire engineering challenge. It moves EMC from being a final validation step to a core strategic battleground. And this slide really lays it all out, doesn't it? The old paradigm versus the new. We used to treat EMC as just static compliance, a final checkbox for internal combustion engines. Now, it's a dynamic strategy. It has to be a core design element from day one. The predictable physics of the past, that's been completely replaced by the high-frequency, incredibly complex world of electric and software-defined vehicles. Okay, so here's our game plan. We're taking a top-down approach. First, we'll define this new paradigm. Then, we'll dig into the tech drivers causing all this disruption. After that, we'll look at the regulatory game changers. And finally, we'll lay out the engineering response that's required. So let's kick things off with Section 1, the new EMC paradigm. We're talking about a shift from a simple compliance check to a core business strategy. Let's start with the answer first. The central thesis here is that automotive EMC is no longer some tactical problem you can solve late in the game. Forget about it being at the end of the V-cycle. It has become a strategic pillar of vehicle design, full stop. And it's being driven by a perfect storm of high-voltage electronics, software-defined vehicles, and of course, new global regulations. So now that we know what's happening, let's get into the why. We'll move to our second section and look at the technological drivers, what can only be described as a perfect storm of high-frequency disruption. The first driver is all about voltage. The industry-wide jump from 400-volt to 800-volt platforms isn't just an incremental change. It's a massive step change in the electrical stress on every single component, every cable, and every connector in the system. And it's all in the name of that faster charging and higher efficiency we need. Second, let's talk about speed. To get more power density, modern e-motors are now spinning well beyond 30,000 RPM. That's incredible velocity. And it directly translates into higher switching frequencies, which pushes the entire spectrum of electromagnetic interference into frequency bands that, frankly, were barely on our radar a decade ago. And third, the semiconductors themselves. The shift to wide bandgap materials, like silicon carbide, has introduced an incredibly sharp voltage gradient. You'll hear engineers call it dV/dt. We're now dealing with voltage swings of over 100 volts per nanosecond. That rate of change is the key to this entire problem. And this is where the physics really hits home. That extreme rate of change, that dV/dt we just saw, it multiplies with the system's unavoidable parasitic capacitance to create these unwanted common mode currents. This isn't just theory, folks. This is the root cause of the high-frequency noise that loves to radiate from cables and disrupt sensitive electronics. This is the source of our biggest EMC headaches. And as if that weren't enough, other drivers are just compounding the issue. You've got integrated e-axles, creating these dense, complex sources of interference. You've got grid-coupled charging, which is a two-way street of EMC challenges, from harmonic pollution to surge susceptibility. And maybe most critically, the software-defined vehicle means an over-the-air update can change a vehicle's entire electromagnetic signature overnight. This brings us right to our third section, the regulatory game changer. Because it's not just the technology that's changing, the rules of the game are being completely rewritten. Okay, let's break down the big one, UN ECE R10.07, which goes into effect in June 2025. First, the frequency range for testing is getting extended all the way to 6 gigahertz. This means tiny little gaps in shielding now matter, a lot. Second, it adds the reverberation chamber as a valid test method, which gives us a more realistic field. Third, it demands specific safe mode requirements for ADAS, which directly links EMC to functional safety. And finally, it allows for rapid FFT-based scanning, which is a huge nod to improving test efficiency. But here's the crucial point. While the UN rule is the global baseline, some regional standards are innovating even faster. Right now, China's GB/T 1865-2025 standard has really taken the lead in defining precise, repeatable test setups for complex components like e-axles. For global engineering teams, this means you can't just follow one set of rules anymore. You absolutely have to look to China to see the state of the art in component-level validation. Which brings us to our final and, I think, most important section, the engineering response. Given all these technological and regulatory disruptions, how must our engineering practices evolve to keep up? The answer is a disciplined shift-left philosophy, and it's built on 3 pillars. First, virtualize. We have to use executable digital twins to assess and fix EMC risks 6 to 9 months before the first physical prototype even exists. Second, automate. Putting human drivers in high-field immunity tests is a safety risk, period. Robotic drivers are now a flat-out necessity for repeatability and safety. And third, adapt. We need a hybrid asset strategy, using mobile testbeds for early R&D and high-performance fixed systems for final certification. It's all about maximizing the ROI of our lab infrastructure. So I'll leave you with a question that really gets to the core challenge for the next decade. When a software update can fundamentally alter a vehicle's electromagnetic signature, is the very idea of a one-time final certification now obsolete? And if it is, what does that imply for our responsibilities throughout the vehicle's entire life cycle?